In this video, I'm going to look at what happens when you are multiplying or dividing an inequality by a negative or by a negative number. So what's going to happen is you're going to be asked to solve an inequality, so something like this. And these ones we're not going to have any issues with. If I ask you to solve this inequality, you're going to try to isolate for x, so you're going to add, or so you're going to subtract 1 from both sides, right? And that doesn't, that has no effect really on the inequality except changing the numbers. Um, so you would solve this as x equals 4. X equals 4. Any number bigger than 4, I could put in for x here, and my inequality would be valid. So I'm allowed to subtract numbers from both sides of an inequality, and there's no problem. In this one, 2x is bigger than 4. Well, the same thing. I'm going to, just like I would with an equation, divide both sides of the equation by 2. These 2's would cancel, and I would get x is bigger than 4 divided by 2, which is 2. Meaning, the original inequality was 2x is bigger than 4, meaning I could take any number bigger than x and stick it in for this value x, or substitute it, and this inequality would be true. So I'm allowed to divide both sides of an inequality by a positive number, and there's no effect on the inequality. But something sort of different happens. So notice what happens if you try to solve we'll go with almost the exact same one we just had. Negative 2x bigger than 10. So you might try if this was just an equation, you'd divide both sides by negative 2. So you might try dividing both sides by negative 2. Right? That's probably your first instinct. Okay, if I divide both sides by negative 2, then I would get, on the right side, negative 5. The negative 2's would cancel, so I'd get x is bigger than negative 5. So that would suggest to me that I could substitute any number bigger than negative 5 into this inequality, and it should be true. But let's try one of those numbers, any number. Okay, what's a number bigger than negative 5? But what if x is negative 4, right? Negative 4 is bigger than negative 5. So if this is the solution set to this inequality, then I should be able to substitute negative 4, which is bigger than negative 5, into this, and it should be true. But what if x equals 4? Then negative 2x is bigger than 10 would be negative 2 times negative 4 bigger than 10. That would say 8 is bigger than 10. And that's definitely not true. This is not true. Right? Last time I checked, 8 is not bigger than 10. So that's not true. So x equals 4 is not in the solution to this inequality. So this solution set must be wrong. So this must be wrong. And the reason it's wrong is because we had to divide by a negative number. Something happens to inequalities when you divide by a negative number. So the question is, what? Like, what went wrong? So what happens when you divide? And this is the same thing that would happen if you multiplied. Actually, let's look at what would happen if you multiply. If you multiply. Multiplying and dividing are similar things. if you want to think about dividing, just think about multiplying the reciprocal. So what would happen if you multiply, or what happens if you multiply both sides of an inequality by a negative? Okay, so let's take some variables. Let's suppose we have, that's not supposed to suppose. Let's suppose you have just any old inequality. X is, let's say, smaller than y. So x is smaller than y. Now if I rearrange this, so if I subtract y from both sides, that would mean x is less than 0. Right? If I just subtract y from both sides, subtract y, and these y's cancel, I get 0. X minus y is x minus y. Which means x minus y is negative. So it's a negative number. Okay. So we have x minus y is a negative number. Now let's try multiplying both sides of the, or actually let's try, what if you multiply x minus y by a negative number? And actually, just to make it simple, let's multiply it by negative 1. What if you multiply x minus y by negative 1? Okay, so I'm going to do a specific negative number, but this you could generalize to any negative number. So if we multiply negative 1 by x minus y, the result should be, remember, this is negative, and this is, from what we set up here, or right here, I wrote it down, this is negative. If you multiply a negative times a negative, you get a positive. So negative 1 times x minus y should be bigger than 0, should be a positive number. Right? Bigger than 0 means it's positive. So now if I just distribute, we get minus x minus 1, or sorry, actually I don't want to write it like that. I want to just write minus 1 times x, and then minus 1 times y is bigger than 0. So all I did was I took this negative 1 and I multiplied by both things. And I didn't even expand, I just left it like that. So now what I'm going to do is add. So I'm going to add negative 1 times y to both sides of this inequality, which we know we can do. We're allowed to add anything to both sides of an inequality, and that doesn't have any effect. So it will cancel these two out. So I'll have minus 1 times x is bigger than minus 1 times y. So now I have this inequality. Well, let's compare that to our original inequality, which said that x was less than y. So look, x is less than y, but if I multiply both sides of this equation by negative 1, which is all I've done here, notice that the inequality is now in the reverse direction. So when you multiply by negative 1, so if I multiply by negative 1 here, and I multiply by negative 1 here, I have to switch, sorry, I didn't switch it there. I have to switch the inequality sign so that it looks like this one. Okay, so that's the rule. If you multiply, and in this example I did negative 1, but it will apply for any negative number. So if you multiply both sides of an inequality, and multiply if you want, or divide both sides of an inequality by a negative, you must switch the direction of the inequality. So a less than sign becomes a greater than, and a greater than becomes a less than. So going back to that example where we noticed that there was a mistake. Where was that? It started up here, right? Here's the example. Negative 2x bigger than 10. So we said we wanted to divide both sides by negative 2. And the mistake we had made is we left the inequality sign as it was. But now we know we have to switch it. So now the negative 2's reduce. X is less than 10 divided by negative 2 is negative 5. So the solution set is x less than negative 5 instead of x bigger than negative 5. So any number less than negative 5, if I sub it into this, will now make it true. So that's the key. When you're dividing or multiplying both sides of an inequality by a negative, you must remember the rule that you have to switch the inequality sign. If you want to avoid that rule, you don't like that rule, it's possible that you never have to do that. So if you want to avoid ever dividing by a negative, just anytime you had to divide by a negative, instead of doing that, and this is the long way, you should probably just remember the rule. But if you don't want to, what I could do is add 2x to both sides, which we're allowed to do. So then these sides would reduce. I'd have 0 bigger than 2x plus 10. Then I could subtract 10 from both sides, which would give me 0 minus 10 is negative 10. These would reduce. 2x. Now I'm dividing both sides by positive 2, and I don't have to worry about switching any signs. So I get x, or I get negative 5 is bigger than x. Usually you'd write that x is less than negative 5. So I get the same answer. It's just a lot more steps, but you save that rule of dividing by a negative, but it's not a hard rule to remember, so it's probably better to just remember the rule.